If you take a standard 300-page book and set it on a desk, the physical weight of it sets an expectation. So when an AI product advertises a 200,000 token context window, it sounds incredibly generous. 200,000 tokens translates roughly to a book of that exact size. It feels like an infinite expanse of digital space. We naturally assume that if we can successfully paste an entire library's worth of text into the prompt box, the system will read and comprehend all of it. But the response you actually get is often surprisingly hollow. You ask a specific question, and the machine entirely misses key details from the text. It summarizes the early chapters perfectly, it captures the closing arguments in deep detail, but anything that happened in the middle chapters is reduced to a vague, high-level summary. The model swallowed the massive input, but it didn't digest it. That huge promised capacity masks a consistent flaw in how the system actually processes information. The first issue is that the empty space you see in the interface isn't actually empty. Long before you paste your document, that context window is heavily occupied. This image shows a breakdown of how that space is actually used. The 200,000 token limit is a total budget across all inputs, not just the text you provide. A significant portion goes immediately to the system prompt. In enterprise setups, this can be tens of thousands of tokens of hidden instructions telling the model how to behave. Then the conversation history accumulates. Every prompt you submit and every response the model generates eats into the remaining space. If the product has access to outside tools, their definitions take up space. And if the system automatically pulls in background documents from a web search, that data gets inserted directly into the prompt as well. The math gets stark quickly. 30,000 tokens for the system prompt, 50,000 for history, and another 40,000 for tools and retrieve documents leaves you with only 80,000 tokens for your actual content. The interface hides this entirely. There is no visible counter ticking down to warn you. You just paste your text, and the system either accepts it or silently rejects it. That 200,000 limit is the landlord's measurement of the entire building. It does not equal the square footage actually available to you as the tenant. But even if your document perfectly fits into whatever space is left, the machine still struggles. Fitting the text in the box doesn't guarantee the machine will read it evenly. This chart shows how transformer models process information. The x-axis represents a long block of text, and the y-axis shows the processing weight, or attention, the model assigns to each section. The architecture dictates that the machine intensely scrutinizes the very beginning of a document, assigning high value to early information. It applies a similarly high level of attention to the very end of the document, retaining the most recently ingested facts perfectly. But any information located in the center falls into this trough. Processing weight drastically drops off, creating what researchers call the lost in the middle effect. Going back to our 300-page book, this explains the hollow response. The specific events buried in the middle chapters effectively disappear from the machine's awareness. The danger here is that the machine will not admit it skimmed the text. Instead, it generates a complete, highly confident response that simply omits the center of your document entirely. The context window is not a uniform reading room. It acts as a distorted lens, magnifying the outer edges while blurring the center into noise. This attention degradation is structural. It is built into the math of how artificial attention works, not a temporary bug waiting for a software patch. To get accurate results, you have to break long, complex documents into much smaller chunks. This forces the model to analyze each piece as a separate, highly focused task. If you must use a single large context window, you have to place your crucial questions or explicitly restate the most critical facts at the very end of the input. Moving those key parameters to the bottom forces them into a high attention position. It alters how the machine weighs the text that came before it. Using these systems effectively requires treating those massive capacity limits as soft budgets. You have to optimize your data for where the model's attention actually is, rather than just filling up the box. We have to abandon the expectation of a patient reader. The promised space exists, but the attention is an illusion.